Welcome to another video by AskMath.com. Let's read the directions. Find the x-coordinate of the point of intersection from the lines produced by the equations. Given 3x plus 4y equals -4 and -2x minus y equals 1. So let's remind ourselves what we're being asked to do here. Remember that an equation that has two variables, like an x and a y, if there's no exponents, for example, will create a straight line if we were to graph it. And we have two equations like that, so it's going to create two straight lines. And many times, two straight lines, when both graphed, will cross each other at a point. And that point is called the point of intersection, where the lines intersect or cross. And that's what we're being asked to find, the point of intersection from the lines produced if we were to graph these equations. And specifically, we're just being asked to find the x-coordinate of that point. So remember, any point on a graph is made up of two numbers, an x and a y, and we're being asked to find the value of x. Now it is possible that two lines on a graph will not intersect each other, and those are called parallel lines. They never intersect. Or you might have one line right on top of another line. In other words, it's the same line, in which case they intersect each other at every point. But this middle scenario here is what we're being asked to find. So there are three methods to be able to find the coordinates, and one is by graphing it. And we don't have any graph paper, so it would be a little bit more difficult. And actually, most commonly, solving systems, remember, two equations or more is called a system. This is a system of equations, and solving is finding the point of intersection. Most commonly, the use cases are computers will need to do this for various reasons, and computers don't graph it, they calculate it. And so a useful skill is to be able to calculate this so that you can give that to a computer and instruct a computer how to do that. Okay, so the other two methods other than graphing are substitution and combination. Now, substitution works best if one of the variables, either the x or the y, is all by itself on one side of the equation in one of the two equations. And here, neither equation has an x or a y all by itself on one side of the equal sign. We've got an x and a y on the left side, same thing here. So substitution probably won't be the easiest method. So we're actually going to use combination. And combination just means that you're adding together expressions like 3x and -2x and +4y and -y together when they are similar. So like terms is another way to say that, another phrase. So if they both have x's, they're like terms. If they both have y's, they're like terms. If they have no variables, they're like terms. So remember when you used to do problems like this, 4 plus 3 equals 7? Well, that's sort of what we're doing here. We're just going to add together the +3x and a -2x and get the result. And similarly with the y's and the numbers. However, our goal isn't just to add them together. Our goal is to add up the x's to make 0 or add up the y's to make 0. And the reason is that we want to get rid of either the x's or the y's in the problem that we're going to solve. So if I add +3x and -2x, I don't get 0. Same thing with +4y and -1y. If I add those together, I don't get 0. So we need to do a little bit of work first. And I see that I can make one change to this -y, and it would make 0 with this +4y. I just need 4 times as many -y's, and I would have a -4y here, which is the opposite of +4y, and those would make 0. So to do that, I'm going to just take my -2x minus y equals 1, rewrite it, and I'm going to multiply both sides. So I put the sides in parentheses. Whatever you do to one side, you have to do to the other side. So I want to multiply this -y by 4, but I can't do it just to the y. I have to do it to the whole side of the equation. So I'm going to write 4 times that side, and then I have to do the same thing on the right side. So the right side of this equation becomes a 4. 1 times 4 is 4. On the left side, I've got to distribute the 4, which means multiply. And so I've got a +4 times a -2x. Remember, the negative goes with the 2x. And positive times a negative makes a negative. And a 4 times a 2 is an 8. and times x. And then the same thing here, positive 4 times negative y. Remember, the negative goes with the term to the right. Positive times a negative makes a negative, and a 4 times a y is just 4 times y. Because I don't know how to do that multiplication, I just write it like that. Okay, so now I've changed my second equation into this by multiplying each side of the equation by 4. Now I'm going to rewrite the first equation below it just to line it up nice, sort of like this. And just to remind ourselves what we're doing, I'm just going to write this line. That doesn't mean divide. It's just sort of like how you used to write problems like that. It means equal. Negative 8x, remember that's a positive 3x. Add those together or combine those, combination, makes negative 5x. Negative 4y and positive 4y make 0. And that's why we multiplied each side by 4 so that we would get no term there with a y in it. Equals 4 and negative 4, so positive 4 and negative 4 also makes 0. Now we are going to write a 0 on this side just to remind ourselves that we didn't forget that there is something over here, which is a 0. Here, since we got the negative 5x, we'll just leave that blank. Now that I just have one variable in this equation, I can solve it. I can solve it for x. So here's where I use PEMDAS backwards. Whenever you solve, use PEMDAS backwards, order of operations backwards. And I say what's happening to the variable, what's happening to x. It's being multiplied by negative 5. And so I'm going to, so it wasn't being subtracted, it wasn't being added, it wasn't being divided, it was being multiplied, going backwards. I'm going to use the inverse of multiply, which is divide, and I have to do it to both sides by negative 5. Negative divided by negative makes a positive. 5 divided by 5 makes 1. 1x is just x. Equals, and 0 divided by anything is just 0. Now, that actually is the number that x equals. This looks a little funny because it's 0, but it's just like any other number. 1, 2, negative 3, doesn't matter. It's just 0. X equals 0. That's the answer to the question. The coordinate where these lines would cross has a 0 for the x coordinate. Okay, and that is the answer to this problem. Thank you for watching another video at askmath.com.